Hi, everyone. Thanks so much for joining us on Zoom today at Venture Cafe for another artist talk. As Natalie mentioned, my name is Angela McQuillan, and I'm the curator of the Esther Klein Gallery, which is part of the Science Center, which is also home to Venture Cafe. I'm really excited to have the artist Michal Gavish as our guest today. Michal has a very interesting art practice. She's working at the intersection of art and science. She received her MFA in painting from the San Francisco Art Institute, and previously she had earned a PhD in physical chemistry. So she has a dual background, and her chemistry background continues to influence her art practice today. So she draws, paints, and creates installations and videos inspired by her science background and her ongoing collaborations with scientists. Michal is based in Washington, D.C., and she currently works as a lecturer in both art and science, as well as a freelance writer and art reviewer, and obviously an artist. So without further ado, please welcome our guest, Michal Gavish.
Thank you. All right.
How are you?
Okay, great. Thank you very much for inviting me here. Do you hear me well? That's okay?
Yes.
Okay, great. So don't need the mic. Yeah, so I wanted to share my PowerPoint with you for this talk. So let me just take a second to do this. Okay. Okay. So what I wanted to talk today is about the more recent work I've been doing. And before this, what I just wanted to say that after studying chemistry and working in pharmaceutical industry, and mainly in the area of solid state spectroscopy, I decided to change into art. So I went the whole way. I went to art school. I finished my MFA in painting in the San Francisco Art Institute. And since then, my art keeps going back and forth into the science. Today, I'll be talking mainly about one topic that always was very interesting to me, and that is color. So we can begin thinking about color in many ways. The many ways are connected to science, like, for example, the work with laser that you often do, etc. And also, in many ways, that are connected to art. Like, for example, Rothko's iconic work is maybe most directly connected for me to color, or to pure color in art. So when I started to work, I started to collaborate with on this project. I started to collaborate first with a biology professor from Stanford, and his name is Ron Brandman. I began microscopic imagery by using this kind of microscopic imagery of proteins and DNA. And one thing that really interested me in this, one of the things, was that the color, this very red color, actually was not a real color, but this was a choice of the scientist or whoever made this program on the computer. So it was actually artificial. It actually had nothing to do with reality. On the other hand, what happened is that as I was looking at these works and thinking what I want to do with them, they acquired to themselves the identity of that color. And that color was associated with things like blood and body fluids. And it started to take on itself this texture, this meaning, without actually being real. And I thought about it that this actually is something that you see a lot in art. Like, for example, when you think about the German expressionism, you have these invented colors that they become the reality after a while. So even though these raw microscope slides already had dimensions of the image being affected by the color, this was actually completely random. So I started to transform these images into a fabric. I painted them I painted them in many ways. I used a computer program called imagery, which allows you to work in layers, which that's how you decode the work from the microscope that I received. And I magnify them. And these are larger than life size, or you can see this better in this work that I've shown last year in Biobat in New York, in my show there. So these images look very abstract. They have this kind of very loose structure, but on the other hand, they are exact images of the microscope samples. And so they look abstract, but they are actually very connected to, at least in their shape, to what it really was. So I was working on this for a while, and in parallel, and this is another one of the iteration of that work, and that is combined also with a video projected on it. And meanwhile, as I was working on this, I started to also investigate or study what is called PDB, which is a protein database. I discovered I wanted to see the structures of proteins, and I discovered that you have this amazing open source program that I could just look up any protein that I'm working on, and I just can take these images, I can rotate them, I can look at them from all sides, in all types of models, etc. So I started to look at them and to paint from them, to work and paint using them. And I made all these kind of installations. These was transfer proteins, which were the first type of proteins that I was working on. And this is work on this installation is on paper. I also worked on fabric too. And these, for example, were the ribosomes that in my current work also became very important because of their connection to viruses, etc. So I took these models, I rotated them, I made several images in different angles, and I started to make video of them rotating, and this was really really nice. And as I was working on this, I was thinking that these actually, the meaning of this is that they actually look like maps. These are actually mappings that show the points at which they map actually the location of the different atoms. Proteins are made of thousands of atoms, and each one of them was shown in this kind of models. So I was very fascinated by this multiplicity, and again, the colors here were colors of the computer, and somehow it was very interesting because we don't know what, there is no color to these small molecules. They are smaller than the wavelength of light, so color has no meaning there. But on the other hand, for me and for many scientists that are working on these models, this color is just so striking, and it's even ingrained, you remember those colors. And so these look to me very much like maps, like you take you code these structures in maps. And this kind of coding of maps, I think, is what brought me first to chemistry. This is another work on paper that I've done. And I was thinking as I was working that this is the type of things that actually connected, maybe drew me to chemistry to begin with. It was this idea that you have this very simple color code that as you get into it, it becomes more and more complex, but it becomes like a language to you. You realize it, you understand it, it's very visual, and there's something very counterintuitive about the thought that all these are very complex, are built with very complex calculations, but in the end, they are really just striking colors. So I continue to do this. There are different types of models that you can have. You can have, and I worked on all of them. I showed this in several exhibitions that I had in the past. It's a big gallery. I've shown this in other shows. I call them then the nano portraitures because I saw them almost like portraits that I'm painting. This is another installation that came out of there. Finally, that was the last one in the series, which I showed also in Biobat this year in the earlier, it also had earlier iteration where I actually built my own molecule, okay? So this is an imaginary molecule, but it does keep all the rules of building a protein structure. So, sorry. So what drew me to genetics, okay, and that maybe is what I'm doing currently, was a very interesting story because I was working for a few years before I started my work at Stanford on another project, and that project was a family portraiture, which I showed in 2014 at a solo show in the Jewish Museum in Budapest. And what I did there is I had 3 halls of very large images that were all larger than life, and they were all my family members. Most of them I never met. And after all this kind of very intense work, when it ended, I somehow started to feel like this was a project, and as a scientist, I somehow need to bring it to some sort of conclusion, to some sort of thought about it. And what it was is that I thought what connects us, of course, what is the theme of this whole show? That was actually our common DNA, and I started to look. That was the first time, and maybe this was the first imagery that I saw for how genetics is displayed by scientists today. And I was simply struck by the colors, by the purity of these colors, and by how strong they are. And they actually really connected with me to these protein models that I've shown you before. So the first work I did here was that I simply embroidered a family emblem for my family, and I did this one that's part of this series that I've made. And I showed it in Art Gallery in San Francisco in my show in 2016. So that actually opened for me the door to genetics, to the thought about genetics and working on it. And slowly, as I started to read more, that's more or less how it works. I started to read more. I started to look more at the images that are connected to it. I discovered that you have this kind of amazing collection of very colorful matrices that are made of these rows and columns of fantastic colors. Okay, and for example, you have today DNA barcodes for many species. They do this a lot. They use this a lot for fishing, for example, to prove that you actually have a good fish every time. And so I started to take these images and to paint from them and to do work, to do installations. And this was the first one. And this is called a reflection. And here, what was really interesting to me as I was working on it and started to think about the meaning of this was the fact that to create such an image and to create all these color combinations, they're not random. These are all based on calculations. So if you think about the calculations, they are, you just go, they are just very complex. If you look at the results, there are tables upon tables of numbers that all have this kind of meaning that give you, for example, the sequencing of DNA. And what happens after all this complex and very fancy math is that in the end, the scientists resort to color, okay? And color is how they show their work, because this is the only way that somebody can actually look at so many data and be able to write a way map, you know, the yellow or the blue, etc., and just to go for it. So this type of new kind of mapping really attracted me, and I started. Maybe there were a couple of works in which I decoded those. I call them keys, and they explain the work and they connect the colors to the different DNA sequencing. But basically, I let the DNA sequencing alone, and I just started to work on this on these images. For a while, I was kind of wondering, and at that time I was really interested in not only at that time, but that started there where I really wanted to put the environment into my work, because I felt like it's such an urgent thing for me. So I started to work on all kinds of crop genetics, look at them, read about them, and then they make these kind of works. These works very often look to me like I was thinking about pixelation, you know, almost like you go at something in low resolution, you all of a sudden discovered all these squares of colors that connected for me to these flat colors. I started to play with this with these focus points and to look at it. How can you see this more generally? How can you get to it closer? And this is kind of a way of looking at data, trying to understand them and to study them. And as I was working on this, this idea of color in color fields of abstract expressionists was all the time in my mind. I really never thought before that that I will ever do this kind of overall paintings, but as I continued with this, I felt like the ground here and the foreground and the background are kind of mixing, and they are going back and forth into, and you never really know which one is the subject here. That was for me a very very striking, this understanding that that's actually what I'm doing. But that's actually was the part of this mapping process. It had to be flat, it has to be all over, and it has to expand on the entire page. Now, the idea of mapping always was very interesting to me, and I thought that this is kind of a tool, you know, it was my tool to look at small things that you really cannot see by the naked eye. These small molecules, you really can't see them, so you get these kind of maps. And maps were always very interesting to me also visually. So I felt like that's actually what I've been doing here. And then, after working for a while on this plant genetics, etc., this is another work. This is work on the panel with the acrylic. Finally, I started to look at viruses, and this happened actually in October. It started, the whole story here started in October 2019 when I visited Philadelphia. That's where I met Angela, and that's when I went to visit Integral Molecular. And I was really fascinated. It was the first time ever that I was in this kind of lab that worked on biology labs. I'm used to chemistry, which is a very different story. And I saw there, there's something about viruses. There's a lot of tension in them for some reason for me. And I started to read and understand them more. And what was standing out there was the fact that unlike very large molecules and very large organisms like us or plants, etc., their genetic profile was so much more limited, was so simple. It's as if it was something so small and primitive. At that time, when I drew this, it was also the anniversary of the influenza. And 100 years earlier was the Spanish influenza. And that was a very talked about material. I saw movies, I read about it, and I somehow felt that it was so contradictory with this scientific material that I see about it, this purple color, this kind of cheerful, beautiful designs. It was almost ironic how they are connected to something like influenza, and this was even more in this work. So when you think about the names of this, like the extreme heterogeneity of viruses, of virus infection, that sounds like pretty apocalyptic. And then you look at this beautiful pink colors, and just there's something so contradictory. And I think that's what actually it's so cool for me working on this subject. So finally, after working and being absorbed in these viruses, started to come all these first stories from China about the coronavirus. And being sunk in reading about this material all the time, I kind of right away took it in a very apocalyptic way, and I thought, you know, just I hope it doesn't come here. And they kept writing in the papers that this is so much more contagious than SARS or anything else that was there before. It was hard to believe that it would never get to us, and sure enough, very quickly it did. And I remember when it started, I was so emotional about it, and so I did this work, which is really very different from all the others that was so calculated. It went back to some work that I've done in the past, and I made this a panel of this virus. Believe it or not, but at that time it was really hard to find images of corona on the internet, but I did find some. And I made a big installation in my studio with lots of mirrors, and I just duplicated them. And I felt like this is the way in which I'm going to kind of like propagate this virus in my studio. But you know, I showed it to some people, got very. It was really kind of scary in a way to look at these, especially considering the beauty of this. So I kind of let it alone. I still have it folded in my studio, but it somehow felt like it was too close. You know, these viruses that were all the time in my beautiful diagrams and maps, they all of a sudden came into this kind of outside my window, and then I had to let go, and I started to work and try to put that also in perspective of the diagrams, and I'm still working on this. It's not finished, but meanwhile I did a couple of works that I just wanted to share with you, and one of them is this alveoli, and these are the small. This image is made based on it's a combination of different views of alveoli, which are the little air sacs that we have in our lungs. So there were a lot appearing in the papers, and that's a place in which the virus actually goes in and attacks. And it looked to me like this kind of a battlefield. But on the other hand, it had this quality of being all over. It had the quality of like it will never end. It never ends on both sides. So this work is on layers of paper and fabric. And then I went completely macro, and I built my last image, which is the image of flanks that are also connected to this COVID-19. And when I look at this, it looks to the images of flanks that I saw started to look to me like what I call a fallen angel. So it's kind of an angel with his head down, and there was something about it that brought me back to all this portraiture that I used to do in the past, away from my color field and my scientific work, but in a way back to it and its meaning. So I think that's all I have to say.
Thank you very much, Michal. Your work is very beautiful, and I really love this like handmade manual process that you're creating from these computer generated data. We're going to go ahead and open it up for questions. We have one question from Diane, who wants to know what's the scale of the Corona installation?
So the basis of the Corona installation is about 55 by 60. That's it's like, and then it's multiplied by mirrors. So altogether, that times about 5, something like this. It's big.
So, do you stand in it?
Yeah, that's it. The point is that you can stand in it.
Yeah, that's really scary.
Yeah, it's a little bit too small to stand in it, but yeah, but you can get into it to photograph it. Yeah, it is scary.
Amazing.
Has your research into genetics been influenced by the pandemic, and are you working on any kind of genetics data based on the COVID-19?
Yeah, so now the last thing that I'm doing now, and that's what I'm working on. I was really trying to finish it for the talk, but just no way, I just couldn't finish it. So, so it's in progress, and I'm going to finish it very soon. Yeah, and that's what I was saying. I was thinking, like, this is, the viruses are so different genetically from us. They're so primitive. They're when you look at their genetics, it's just so much smaller. There's so much less to it than ours. Yet look at this. They can just go and do whatever they want to. All of us was so much more advanced than them.
Mm-hmm. Eddie's question, can you talk more about the relationship between color field diagrams and your portraits? Seems like at the final images you showed you are combining all.
It's kind of maybe in this one. Sorry, it jumped. Yeah, I am. The point is that once I started with these color fields, they took over, so if I would have made an image like this, I don't know if the color would be so important for me, and also the fact that I'm using more or less one type of color. So I think that's one of the things that is important about these color fields for me, that these are very uniform,
Yeah. Claudia also wants to know, you mentioned intensity of color, but what about the translucency of your use of color? Can you talk a little bit about that?
That's actually yeah. First of all, yeah, my work is translucent, but I do when I paint it on the fabric, because the fabric itself is very thin, so you can see through it. And what I'm trying to do is to layer this one on the other to create the intensity, but the intensity is just aerial. Rothko is one of my really icons for many years. For every time I see his work, it does to me something that other works don't. And I feel it's something about the edges, the soft edges, actually, not just the intense colors, etc., but the soft edges for him. That actually draws me, and I think that might have been the reason for, I don't know, but that might have been part of why it sounds like that.
We have a comment. Wonderful work. What fabric do you use and how many layers?
Okay, so it varies. I go up to 5 layers. When you do more than that, you can see it. And I use all types of organza to do this work.
Okay. So I'm kind of just wondering, what kind of work were you doing as a chemist, and what kind of sparked this change in your life where you decided to get an MFA in painting?
Yeah, that's a very good question. Yeah, so I was working on what is called spectroscopy. I'm just trying to on spectroscopy, mainly on things on solids, if that defines it a little bit more. I was working in pharmaceutical companies. I was also I studied it before I did my PhD on it, and the connection to all this from that is the fact that when you do spectroscopy, you're actually taking a tool and looking at things that you can't see, things that are too small. Okay, our eye can't see things that are so small as these molecules and atoms, etc. So what you do is you actually use other kind of radiation, like X-rays, or NMR, or infrared spectroscopy, and all these, and you just look at them, and you kind of make all kinds of assumptions, and from this you get all these models that you saw before, and determine what these things look like. So that's kind of the connection. I was working in my last job as a scientist. I actually started to paint more and more, and I was painting portraitures there actually as a scientist, and slowly that just took over me, and we went to California with my family, and then I thought I'll take a year off. That was my plan, and the rest was history. You know, I took a couple of classes at San Jose Institute, and
yeah, that's a unique path, but I feel like there are a lot of scientists who are also artists and vice versa.
yeah.
So I'm kind of wondering, how do you currently get access to the laboratory? I know you're teaching. So is this something that you get through your teaching, or do you collaborate? Like, how do you find scientists to collaborate?
So I Professor Brandman from Stanford. I used to live there in California next to it, and I met him through friends. But many other scientists that I've worked with, like actually I think Wood Stark is here. Are you there, Wood? Yeah, Wood Stark is here, and she. She's right here, and she was my first collaboration. Even before that, when I was in Silicon Valley, and I had to do a project for 01, which was the art and technology biannual. And I started to work with her. She gave me a lot of her images, and she gave me actually the first proteins that were dancing on my video. Do you remember this, Ruth? That was really cool. So I just have a couple of friends that I work with. I have another friend from UCSF who is working as a radiologist, and she was with me in the Whitestone Institute, and we are friends until now. And she gives me a lot of. I did with her some projects, etc. So I just actually know people personally, and that's how I begin this work. And the genetics actually is my plan to work with my friend Sofiara, who is I used to work with her in Switzerland in pharmaceuticals there, and she's still in that area. She works now for the Royal Institute in London, and she already gave me some images, and I'm starting to work on it.
Wow. We have a comment from Ruth. She says, I wonder if it's weirdly ironic that you worked in spectroscopy and are now exploring color in your art.
It is in a way. Yeah, it is in a way. It's a very, you do spectroscopy, it has such a wide range, and then you just settle on this small visible range, right?
I hadn't really thought of this connection until you were asked about it, but spectroscopy involves taking the idea of a rainbow of colors and extending it much further. And it's just ironic that now you are sort of in a way back to your scientific roots in a different way, speak by exploring color. So I don't know.
Yeah, that is very true. And I really didn't expect this, but as soon as I started with that first video that we were talking about before, it just went on and on and on. And now I'm almost working only on science, basically.
Wow. All right, well, thank you so much for presenting your work today. It was really amazing, very inspiring, and you got a lot of comments. And thanks for joining us today, everyone.
Thank you.
Thank you very much, Angela.
And thank you, Michal. It was fascinating.